Good evening, everyone. Today we are having Dr. Nitin Bankar with us. Nitin sir will be talk on electricity generation through solar energy. Dr. Nitin is currently an associate professor at School of Engineering and Applied Science, Ahmedabad University, Ahmedabad, Gujarat. He has obtained his PhD degree from Indian Institute of Science, IISc Bangalore. He has 14 years of industrial experience and academic experience. His area of interest includes conventional and heat-operated refrigeration systems, thermal energy storage, and solar thermal energy. He has completed one Department of Science and Technology funded project and guided two PhD students. He has published two Indian patents, 17 journals, and 19 conference papers. Now I welcome Dr. Nitin Bankar for his talk. Welcome.
Thank you, Dr. Nikhil. So I'll share my PPT. It is visible, right?
Yes, sir.
Okay. Good evening to all, one and all present here. Myself, Nitin Bankar, and I'm associated with Ahmedabad University, and I would like to thank Dr. Nikhil and his team for inviting me for this talk. And the topic here, basically, whatever it is, we are looking for energy management for sustainability. So the topic is very much relevant, and I'll be talking with respect to India, so which is again very important for us to know that what is the status and how we are going forward with this solar energy. So the topic which I have taken is electricity generation through solar energy in India. My presentation I have divided into few subtopics. First, I'll be talking on energy scenario in India. Then why we are talking of solar energy in India. Okay, so that is another thing I'll be discussing on that. Next, I will talk on one technology which we are aware, that is solar photovoltaic system. And then later on, I'll be also talking on solar thermal energy, which is again one of the technology through which we can generate the electricity. And at last, I will be talking on future prospects. So to start with energy scenario in India, so if you see and look back last 3 to 4 decades, we have significant rise in population, and with that also industrial development. Okay, so both these things are combiningly what they are doing is like they are with this we need a lot of energy. Okay, and because of that we had seen tremendous growth in power generation. And if we talk of India, so in India, basically, you see this chart here, we can see that 2009-10, this year we had the electricity generation was around some 771 terawatt hour. And I think people might be aware what you call as like 1 unit, right? 1 unit of electricity, it is nothing but 1 kilowatt hour, right? And we consumed like around 771 terawatt hour of units in 2009 and 10. And if you see that electricity generation in 2018-19, it was around 1249. So almost like 160% rise in the electricity we have seen in last 10 years. See, 1250 terawatt hour. Okay, so this is huge. 160% is huge, and that comes from this again population and industrial developments. And to give the example, you see like our consumer thing, home appliances, that also increased a lot. We go back and see in 2005 and 6, at that time, the mobile, it was like very few people were having the mobile. Now everybody has the mobile. Like that, home appliances. If you talk of, let's say, I'm giving one example of sales of air conditioner. If you see in 2005, we had sell of almost 1.1 million units. Okay. And if you see in 2010, 2.5 million, and 2019, it was like 6.7 million. So almost like 600% rise in the air conditioner selling. And I think people again aware about the electricity at their home, that if you use AC, almost 50% of the electricity bill, it comes due to the air conditioner use, right? So it means like air conditioner is consuming huge electricity, and that is what very important here. Like that, many other appliances are there which is actually consuming electricity, and we increased their uses, and because of that, our electric generation, we require a little bit more. We need more energy. Again, for India, if we talk that in 2018, this is 2018-19 data, whatever electricity we generated in 2019, 18-19, the energy came from these resources. If you see, coal, that is almost like 70.5% of electricity, it came from coal. Okay, we burned the coal and then generated the electricity. Then if you see here, 3.5% it is coming from natural gas. So almost like 78% of the electricity, it came from coal and natural gas. And I think again, people might be aware that what we call this kind of the resources, this we call as conventional energy resources. So these resources are limited, okay? And we also call fossil fuel. So our maximum power generation, it is coming from this fossil fuel. And now people are aware again about the climate change, environmental issues, and we know that by burning these fossil fuels, we are generating greenhouse gases, and that is impacting a lot to the environment. Okay, so what should we do? So we should actually reduce this kind of the energy resources, but then from where the electricity will come? Then we have to actually shift towards the non-conventional energy resources, and these resources can be wind energy, solar energy, biomass-based energy, geothermal energy, and hydropower. So these are the resources which are, you can say that, environment friendly. They are not affecting to the environment. So we should actually move towards that. Now, why we talk of solar energy in India? So now solar energy is very much advantageous for India. Why? So few reasons. So one of the reason is, if you go and see in India any location, okay, you can say 80% of the location you will get 300 clear and sunny days. Okay, so 300 days are like that you will get full sun. Okay, so it will not be cloudy. Okay, out of 365, so almost like 10 months you will get full sun. And the availability of radiation, you see, 5,000 trillion kilowatt hour, this much of units per year of solar radiation, it is coming for India. So I'm talking of India only. Okay, this much of solar radiation, it is falling on Indian land. Okay, and if you just compare with possible energy output of all fossil fuel energy reserve for India, it is higher than that. So which is you can say that is, I mean, in advantage for India. One more thing, see, if we compare with the wind energy, then solar energy is not specific, I mean location specific. Okay, so here if you want to install wind energy resource, okay, windmill, if you want to install, then you have to look for where your you will get more wind. Okay, so these locations may be seashore or maybe hilly regions, there you will get more wind, so you can install the windmill. But other locations you can't. But solar energy, it is available in most of the region. One more advantage is, see, if I want to install maybe hydropower or maybe wind power at my home, my terrace, I cannot do. But solar energy, of course, I can do. On rooftop, I can install the solar energy. So that is why for India, this solar energy, it is going big way. If I want to generate the electricity, what are the technologies? So there are mainly two technologies. One is solar photovoltaic system. So in short, we call PV system. And another is solar thermal energy. See, both the ways we can generate the electricity. Now let us see one by one. Okay. Solar PV system. I think again, people are very much aware about that one. What is that? PV system. So this technology is basically, if you put panel on the rooftop in the sun, it will generate the electricity. You will get the electricity. Here the efficiency is around 10 to 15%. The meaning is, let's say 100% radiation falling on this panel, only 10 to 15% of electricity it is converted, okay, from the radiation. In India, it is popular. The reason is, see, it is first thing is, it is generating directly electricity. You don't need anything, okay? You need just panel, just structure to hold that one, and then you will get the power. That is what is simple in construction. And I'm just giving some idea of that in India where more solar power it is available. So this location, if you see Rajasthan and Gujarat, here Maharashtra, Karnataka, Tamil Nadu, so you will get Andhra Pradesh. In this region, more solar power it is available. And the other regions, this region also solar power it is available, just slight less than what it is available in Gujarat and Rajasthan. Okay, so this region it is a little bit less, eastern region and Jammu Kashmir. Otherwise, most of the region you will get good solar power. Here, let's say PV power generation in India. So if you see the data in 2013, okay, 13-14, how much solar power we have generated? Okay, so it is 3.36 terawatt hour. Okay, and if you see in 2019-20, 50 terawatt hour. So you see how much, almost like 1700% rise in the solar power. Okay, so in 2013, whatever we were generating, more than that we are generating now, and still it is going ahead. We are going with that one. And this is data of 2019, July 2019. We have almost like 30,990 megawatt of installed capacity we have. Out of that one, ground mounted solar power, it is 27,930. Solar rooftop, we have almost like 2141 megawatt, and off-grid solar power is 919 megawatt. This data, it is taken recently to just show that what is the solar power generation in India through this PV power. I'm giving some power plants located in India of around some 2050 megawatt, which is located in Karnataka. It is Pavagada Solar Park. One more, it is Bardla, which is 15 megawatt of capacity. And like that in Gujarat, Tamil Nadu. And I'm just showing some few power plants only up to 250. Less than that, still many plants are there, but I just showed the top few plants which are generating the electricity through this PV power. Okay, now I am coming back to a very important issue with this PV power: sustainability. Okay, now if you see solar radiation, if you measure it. See, in the morning time, let's say I'm talking of, let's say 8 o'clock. 8 o'clock, we have almost like 200 watt per meter square. So if you have 1 meter square of panel, then you may get around some 200 watt of electricity you can generate. Okay. And sorry, 200 watt of solar radiation falling on that one. Okay. And when the days go ahead, the radiation intensity, it is increasing. It is becoming maximum at 12 o'clock. Okay, so around some 900 to 1000. Again, this is for data for Silchar, and for other location it will be different. Okay, let's say we talk of Delhi, we talk of Rajasthan, some location, or Gujarat, or somewhere else. So this number will be little bit different, but the trend is same. So morning it will be less, around 12 o'clock it will be higher, and then it will be decreasing. Okay. Now this is for one day I'm talking. Let's say if we take off of different seasons, let's say we have winter, summer, and then monsoon. Again, this intensity data will change. Okay. Now let's say what I would like to say here is that the solar energy is varying in nature. Okay. So it is in the day it is varying, as well as every day it is varying. Okay, with season also it is changing. And one more important thing is, after sunset you will not get the solar energy. Now I'm giving one example. Let's say you have one community and you want to supply, let's say 5 megawatt of power. Okay, and let's say near to this community we are installing one 5 megawatt PV power plant. Now let's say community, it requires 5 megawatt in the daytime, and let's say 2 megawatt in the night time. Okay, this much of power requirement it is there. Now my power plant, which I installed of 5 megawatt, let's say I start it in the morning time. How much power it will give? It will give, let's say, in this time duration, let's say 8 to 10 o'clock time, it will give 5 megawatt power plant. It will give me 2 megawatt power. But how much we need? We need 5 megawatt. We need 5 megawatt. We got 2 megawatt. And let's say during the night time, we want 2 megawatt, but we don't have solar energy, so we cannot generate the electricity during the night time. Now what to do? I mean, so this is not sustainable solution. You see, here, if I want to do management with the grid power, it is difficult. Okay, I want 5 megawatt, but I am not getting it. I want 2 megawatt, I am not getting it. Let's say, okay, let's do one thing. I am installing 10 megawatt power plant. Let's say 10 megawatt I am installing. During the daytime, I need 5 megawatt. Let's say in this time, you will get 5 megawatt. And around 12 o'clock, okay, you will get 10 megawatt. Now, I need 5 megawatt. I installed 10 megawatt. I am generating 10 megawatt. What to do with this surplus 5 megawatt? Okay, again, the issue is same. In the night time, it is not generating anything. So again, I need 2 megawatt. So I'm not getting it. So now that is what the problem with this photovoltaic power generation. So that's why I'm talking of this sustainability. What to do with this situation? So there are two things. One is you install one more power plant, okay, which is conventional energy based power plant. Okay, now we talk that we don't want to use the conventional energy, but then because of the issue of solar non-continuous solar power, we have to go for this conventional energy based power plant. Okay, so again, we will not go ahead with that one. Then one more thing is you store the energy, so you store the electricity. Okay, that is another solution. But then, okay, in everybody's mind it will come that, okay, we want to store energy, let's go ahead with the battery. Okay, so we will design the battery which will store the energy. Okay, small scale, it's okay. Maybe if you want to store 10 kilowatt of power, it's okay. But you are talking of 5 megawatt, 10 megawatt, you are talking of 100 megawatt. That much of power you can't store in this electrical battery. Such batteries are not available. Okay, so, and one more thing is, even though if you use for smaller scale, this battery is not solution. I mean, this is having shorter lifespan. It is not environment friendly and expensive also. In 2 years time, you have to replace it. So large capacity, if you want to go, there is no solution. What to do with that one? So that is why there is sustainability issue. You cannot get continuous power as per the demand for the community with the photovoltaic system. Okay, now let us look another technology which we call solar thermal energy. This technology, what it does is it converts the solar energy into thermal energy, okay, heat energy. So we will have solar collectors. So basically these are the mirrors which will reflect the energy and concentrate somewhere, okay, and this whatever concentration of radiation it will happen, so that we can convert into heat energy, and this heat energy, with that heat energy we convert the water into steam. This steam we supply to the turbine and we can generate the electricity. Here the efficiency is 30 to 40%. So whatever radiation it is coming, we can convert 30 to 40% of that one radiation into electricity. Now the problem which we faced in PV power, okay, here the solution is, now this heat we can easily store in thermal energy storage material. Okay, so whatever heat it is there, you store in some materials, and whenever it is required, you utilize that one for the power generation. That is why, as per the demand of electricity, you can generate the power. So you store the energy, and then whenever you need, how much power you need, accordingly you change, do the some changes in the mass flow rate of that steam. With that, you will get the power. And two main systems are there in solar thermal energy which will generate the electricity. One is solar parabolic trough and another one is solar power tower. Now I'll be talking one by one this two. Let's look solar parabolic trough. Here, see, here we have, you see this parabolic shape, you can see, right? These are the collectors. So basically radiation falls on that one and it will divert. So it will divert, and here at the focal point of this parabolic shape, we will have receiver. Some absorber tube will be there in which the fluid will be flowing. So this fluid, it will actually capture this radiation. It will convert this, let's say we talk water, it will convert into steam, and that steam we can utilize it. That is what simple construction for this solar parabolic trough. Let us look the plant where we can generate the electricity. You see here, this is my parabolic setup. Here we are generating the steam, and this steam we can take to the turbine. This turbine will run, it will generate the electricity, and whatever exit of that one it is there, we are taking to the condenser where we will reject the heat, convert into liquid form, and once again we are taking to this parabolic trough. Now this is what day scenario. During the day, our cycle will work like this, in this manner. Okay. Now during the daytime itself, what we will do is some of the heat we will store in this thermal energy storage. Now during the night time, okay, this will not provide me the steam. From here we will generate the steam, and my cycle will work now in this manner, smaller circle. Okay, so night time, and by varying the mass flow rate of the steam, we can actually get whatever my electricity generation it is required. So with this, we can have excellent management of the demand of electricity. Similar kind of setup it is there for the another solar thermal energy technology, that is solar power tower. So here what we have is one tower we have. This is your tower. At the top of the tower we will have one receiver, and we will have a lot of mirrors. Okay, we call as heliostats. Okay. These heliostats are basically reflecting radiation towards this receiver. So here receiver, it will have a lot of concentration of the radiation. What we do is we will have some storage tank here. We will pass some heat transfer fluid. Maybe water may not be good idea because its boiling point is lower. Okay, and so we can use some heat transfer fluid which will have higher boiling point, which will pass here, which will take the energy from here, high temperature fluid, it will go, and then we can store in this thermal tank. Okay, now this will have hot heat transfer fluid, higher temperature. Basically you can generate the temperature maybe up to 500, up to 1000 degrees centigrade, even 1200 degrees centigrade also you can generate with this heliostat setup. So we will have turbine, we will have your water flowing here. So through heat exchanger, we will take this heat, convert into steam. It will go here, it will run into the turbine, it will generate the power. So by varying the mass flow rate, whatever my power it is required through this turbine, we can generate. And again, here also we can actually get, as per the demand, the electricity generation we can do. Moreover, this kind of the system, it is having higher efficiency than the previous one because we are able to produce higher temperature than the solar parabolic trough. And I have given one picture here. So this is of one location in Spain. This is 11 megawatt of solar power tower. Here you can see, so this is tower and these are the heliostats. This heliostats receive the radiation and then it is concentrating on this tower receiver. Okay, and with that we can actually running our power plant. So we can generate the electricity. So you see, we have certain advantages of this solar thermal energy over the solar PV. We can actually have excellent energy demand management. So as per the demand, we can actually generate the electricity.
I have a question on the previous slide.
Should I answer the question? Maybe I think some 2 or 3 slides are there. Let me finish and then maybe whatever your queries are there, maybe I can answer.
Okay, fine.
Yeah. Then we have here higher efficiency. So efficiency is little bit higher as compared to solar PV. The land area required, whatever the land area required per megawatt of power generation, it is as compared to solar PV, here it is less. And one more thing, see, let's say in community, so you know, you don't only need the electricity, you need heat also. See, we use solar water heater, right? So like that, we need the heat. In industries, many places we need the heat. Okay, apart from electricity, we need the heat. So here we can actually get the power as well as we can actually produce the heat, because the exit of turbine, it may be at higher temperature of maybe 70-80 degrees centigrade, which we can utilize. And what will happen is the combined system, power and heat, it will give me higher efficiency. Okay, so that is again one more advantage as compared to the solar PV. Now let us talk of in India, what is our future regarding this solar energy systems. So in India right now, if you see installed capacity of solar power PV through PV, it is 35,122 megawatt. Whereas solar thermal power, it's just 227 megawatt. See, we have huge difference. More power we generate from the PV. But then again, what I told, that PV, there is sustainability issue. Okay, so there is huge scope to promote this solar thermal power, or you develop the solution with this PV, with which you can actually get sustainable power. Means whatever your demand is there, accordingly you generate through this solar PV. So you develop the solution. So these are the future work where a lot of work is in progress. And I just want to give some idea of that currently, what kind of the research works in progress across the world in these areas. One is cogeneration, which I just now said, right? Heat and power. Okay. Another one is trigeneration. So you generate power, you generate electricity, and there are certain kind of refrigeration systems, absorption system, okay, adsorption systems, refrigeration system. They generate the refrigeration by using the heat. So you can generate power, heat, as well as the refrigeration. So a lot of people are working on that kind of the system to increase the efficiency of total system. Again, you see, we have seen thermal energy storage materials are playing very vital role in this technology. So a lot of people are working, they are developing more efficient materials which will have higher effectiveness. Okay, so a lot of people are working here. Now, see, we have solar PV, we have thermal energy. People are working on combining these two, okay, so that you can get advantages of both. So people are working on that one, so you can get combine solar PV, and then you can actually manage. So a lot of people are exploring it. One more thing, yes, I told that solar PV you cannot get in the night time, but then there are certain systems. One of them is this compressed air energy storage. So what you do is you install high power PV power plant. Whatever surplus electricity you will get, you store in this compressed air form. Okay. So after storing, let's say night time, this compressed air, with this compressed air, you run the turbine. With that, you will get the electricity. Whatever your demand is there, you vary your mass flow rate of the compressed air. Okay. So with that, you can get the electricity. So again, commercially, this is not very much available. A lot of people are working on it, and few places in the world, they have installed this compressed air energy storage, but still it is not very much connected with all the plants. So still the efficiency issues are there for this kind of the system. So a lot of people are working on that front, how to increase the efficiency. So with this, I'm completing my presentation, and thank you for listening me, and also thank you for inviting me for this lecture. Yeah, so now if you have any question, maybe we can discuss it.
Now session is open for the questions. Anybody having questions can unmute himself and ask the question.
Please come back to the slide which is related to solar thermal energy.
Okay, so you want to talk, I mean, you want to see this one?
Next one, this one. No, next one.
Yeah.
Yeah. So how this radiation is captured?
See, yeah, it's like mirror. Okay, so these are the mirrors of area of maybe 50 meters square, 60 meters square. Okay, that kind of the you can say 1 meter square area of mirror it will be taken, and then one big structure will be there, flat structure, and on which this mirrors are attached. So what it does is this solar radiation falling on that one, it will now this are automatically controlled by this computer program. Okay, so because this sun moves, whatever your sun movement it is there, accordingly this mirror will move.
I see. So orientation of mirrors, all mirrors will change.
Yes.
By different degrees, because their position is different.
Yes, because their location is different. So for each mirror, your rotation will be different.
Oh, I see.
Okay.
Okay.
So this all will be computer, we can control, and without it you can't. Otherwise you cannot get the concentration of radiation. So this all are controlled very well by this computer programs. And you know, like this heliostats are almost like 1,000, 1,000, 2,000, something like that.
And is it commercially viable solution?
Yes, this is available. I mean, in India it is not there, but in US many places. So this is actually a running plant, 11 megawatt in Seville, Spain, and likewise in US also many plants are there.
I see. Interesting.
So the receiver also.
प्रोफेसर साहब प्रवीण हियर, मेरा एक क्वेश्चन है इस स्लाइड पे, rather two questions है. अच्छा, before that, Dr. Nikhil, I'm saying one of the way probably you can say the people who have the questions, they can type in their name in the message chat so that you can take it one by one sequence wise, so that it would avoid multiple people asking the question again at the same time. So my question is on this solar power tower. What is the kind of area required for install per megawatt of electricity requirement? How much area is required for installing this heliostat and receiver? I'm saying, what is the kind of?
Oh, that exact figure I don't have right now.
A broad figure will also. I'm just comparing it versus a PV solar power panels which we install, right? Which is more horizontal, and then we collect the solar power and then generate the electricity. As compared to that, does it require more area or less area? I'm saying, and what percentage? I'm saying it require only 60% of the area.
Yeah. So as I said, like in one advantage is here, the you see the land requirement is less. So less. So very much less. So you see, like efficiency point of view, if you see that PV power, it is just 10 to 15% efficiency. So maximum you may get 15% at 12 o'clock, but then 8 o'clock, 9 o'clock, you will have less power. So on an average, you can say it is around 10%. Okay. Now 90% of the solar radiation, it goes wasted. I mean, it is going into the atmosphere back. But here, whatever radiation it comes here, falling on that one, you can say almost like 80 to 90% we transfer to this receiver.
Okay.
But then again, you know, like our thermal power plant, right? If it is coal based, our efficiency is 35 to 40%, right? So here also you can say that our loss is not here. Our loss is in that power generation.
Complete cycle, okay.
So that is why, see, in that category it will come. So 30 to 40% of power.
So still you mean to say, even if it is delivering 30 to 40% of the efficiency, it is 3 times, you know, if you just calculate versus PV cells, right? Which we normally install in India.
Yeah.
So still it is 3 times more efficient as compared to that. I'm saying it can be the same, right?
Right. So you have to keep in mind that for PV, you just need the panel. Okay. And here you need, okay, this heliostat's fine, but then you need that steam turbine.
Yeah.
I mean, so so investment cost here is little bit higher than what it is there in the solar PV panel plant.
That was my question actually. So what I'm saying, what we understood from one of the slides from Dr. Nikhil a couple of weeks back, that average installation cost for a solar park to generate electricity is roughly around 5.5 to 6 crore per megawatt, if I remember correctly. Yeah. So if we just see it from that perspective, how much this will be the cost?
I'm not very much knowing the data, but you see, the things are like this. Solar PV right now, the per unit cost we get, like let's say it is like 2.5 rupees or 3 rupees in India.
Okay.
But then here the cost is higher.
Cost per unit will be higher.
Will be higher. That is what. That is why. See, you see, in India also, like people are going for PV power only. I mean, so it's not coming in big way. But a lot of, again, where the cost is going, because the initial cost is higher. Because of that reason, it is still a lot of work is in progress to increase its efficiency, to reduce the cost. And you know, again, PV power, it cannot give me 24 hours solution. That is what the big difference is. So in India, we have to think, the government policymakers have to think that only PV power, it will not work. You have to go ahead with the solar thermal, or you have to find out the solution for sustainability. That is what the main issue is.
Which means install very large batteries to store the energy during daytime.
Which is not feasible.
Which is not feasible.
Battery, it is not a solution. See, you go with PV power plant and one more conventional energy based power plant, then it is okay. But then we want to avoid it. So,
Correct.
But then here this 24 hours you can get the electricity.
Okay. And another question is whether this heliostat can be installed vertically also?
See, this we have to rotate actually, right? According to sun's position.
Correct.
Okay. So, see, if we install vertically, it will not be able to, again, it has to rotate as per the sun's position.
Right. Okay, now my question was, let me tell you the background why I asked this question. Like there are large towers, right? Vertical towers in many places. So in cities particularly, right? Where you don't go horizontal, rather you go vertical. So I'm just thinking from solution on that side, that if you have large vertical tower.
There is possibility, whatever angle you want to keep, but then it will not be in one position. See, every time you need to change it.
Yeah. Okay.
But our position you can change. I mean, this instead of, if you want to keep that vertically, your tower height may be decreasing.
So out of these three systems, Professor, which you just explained, which is solar power tower, solar PV cells, and third one was
parabolic trough.
Parabolic trough. So I'm saying, if we see technically, how do we rate these three systems in terms of their efficiency and commercial viability?
Yes, so this is the best.
This is the best. Okay.
This is the best. The reason is, you see the temperature which we are generating here, it is quite high. You can get maybe 600, 700, 800 degrees centigrade here. With thermodynamics, if my system is having higher temperature, I will have higher Carnot efficiency, right? So in parabolic trough, the temperature which we can generate maybe 300, 350 degrees centigrade.
Okay.
So here our efficiency is better than that one.
Okay. So this is the best than the parabolic one and then the solar PV, right?
Yes, yes. But then you see, like parabolic trough is little bit easier as compared to this one. And again, as compared to PV, both the systems are good.
Because why I asked this question, maybe almost, I think 7-8 years or even more than that, there is at the Kuwait International Airport, one of the leading consultant designer installed a parabolic trough kind of panels to generate, I think, how much electricity? It's a large amount of electricity which they're using it to run air conditioning plants and some more thing. So I was just wondering if this system probably require less land area versus that parabolic trough, and it can provide round the clock this thing. Of course, parabolic can also do, but
yes.
I think that it can generate better than that.
Yes.
Either this technology probably may not be there that time, or it is not that much commercially viable. I don't know.
People are doing since long time, but still you see that cost has not come down. So that is why replacing PV, it is becoming difficult.
Okay. So I think the major cost in this is coming from the power generation cycle, which is turbines,
initial because you have to install a lot of.
So once this cost comes down, or the alternate
yes,
then probably, or it can be used as a tri-generation, as you're saying, when you have.
So that is again. So you have to plan.
Combined efficiency of tri-generation system probably will overpower all these other issues. Like in that we are normally using only for electricity.
Right.
Okay. Thank you, Professor. Very nice presentation.
And
Thank you.
I have one more question.
Sir, I have an add-on question.
Yeah. You had mentioned about the combination of PV photovoltaic cells and compressed air, the technology which uses these two things. So how effective is that?
So
Has it been
what
used
generally it is,
commercially?
again, this technology, compressed air energy storage,
Yeah.
commercially it is not many places it is available. Actually, you can see people are exploring it. So some places in the world, in Europe, I think some 2 places, if I remember, US and Europe. I think some 2 places it is there for larger plant, but
Okay.
everywhere it is not there. Again, what happens is when you convert that electricity into compressed air, then this compressed air to when you generate the electricity, that round trip efficiency we call round trip efficiency, it is lower. I mean, it is 50 to 60%. Okay. And you need the turbine, you need large storage. So that is why, again, a lot of work it is in progress so that you can actually reach to good round trip efficiency. So people are working. So now these are, you can say, hot areas
So in
where
that
people
case,
are putting their efforts.
air turbine will be used.
Yes, air turbine you can use.
Okay.
Yes. Any other question?
Sir, yes.
I have joined late. Sorry, go ahead.
Yes,
So can I
please.
ask?
Yes,
I
yes.
have asked a question that can we use compressed air with photovoltaic as well?
No, I'm talking of, see, compressed air, it is with photovoltaic only. Because see,
Okay.
I told that with the PV, we want one solution. So one of them is this one, compressed air. So you put plant of higher uh, power with the PV and you generate extra electricity, you store in compressed air, and nighttime you can utilize.
Right.
In solar thermal energy, we don't need compressed air.
Okay. Okay. All right. I think makes sense now.
Yeah.
Professor, what was compressed air? Sorry, I missed out because I joined 5 minutes late. Is it something which you explained already?
No, I just told actually I told earlier that see, PV power we are using a lot, but then we don't have solution for nighttime. Nighttime, how we'll get the power from solar? Okay, so what you do is like, let's say you need 2 megawatt of power during the daytime. You put plant of 4 megawatt, so you may get 2 megawatt additional surplus energy, which you utilize for compressed air, and then that compressed air, with that compressed air, you run your turbine during the night time and you get the electricity. That is one solution.
Oh, okay. But the turbine running with the air compressed air, the efficiency will be much lower versus that steam turbine, right?
Again, I told, right? So this is not commercially very much people are using, but people are exploring so to increase the efficiency so that they can reach to the level that they will lose minimum energy. When breakthrough will come, you will see all the plants will connected with this, because you see the numbers. See, in India, this 227, and here it is 35,000. And this is the same scenario for world also. Similar kind of scenario it is there.
Okay.
Now we are having some question, Mr. Naveen. Mr. Naveen, you can unmute yourself and ask your question.
Yes, sir. So first question is that the space requirement that you are telling for solar thermal energy, is it less because of the efficiency that is greater, or is it
Right.
less in like a literal sense? It is less for the same power generation megawatt capacity.
No, the first thing is efficiency. You see, per meter square area, let's say 200 watt, let's say 1000 watt it is falling on solar PV, 1000 watt it is falling per meter square. 10% of that one means you will get 100 watt, right? And in case of solar thermal, if 1000 watt it is falling in per meter square area, you can actually get heat of 300 to 400 watt, and that you are converting into electricity. So maybe you may get some 200 or something like that watt of power. See, so
Yes.
that is why you are actually getting more, you can say your efficiency is higher. Because of that, you can get your land area can be reduced.
Okay. So it is due to only efficiency, like there is no literal difference between the area for same power generation.
Yeah, it's efficiency, right? Yeah. So per megawatt power generation, your land requirement will be much lower.
Okay. Okay. So one more few question I have. Can you explain the thermal storage system, like how we can store steam at a certain temperature and pressure? Like what are the devices, if you can put some light on it?
Okay. See, what it is there that, let's say we have steam, which is okay. Now, generally, what we do is, let's say you are having parabolic trough. Okay. Now this is parabolic trough, and what we do, some heat transfer fluid we will use, or let's say water we are using here. Water, now we will have pump here, and with that actually we are increase the water pressure. Okay, if we increase the water pressure, maybe 30 bar water pressure, okay, 40 bar water pressure,
Yes,
so your boiling point of water, it will increase, right? So with that, what will happen is, your maybe 300 degrees centigrade also, it will be in the water stage only. Okay,
sir.
so this we will take, and then in this some kind of material it will be there. Or let's say, what I will take is, let's say, candle. You see, the candle, the material is uh,
Wax.
phase change material. Okay, so what happens is this candle material, that wax. Let's say wax we are having, we filled in this cylinder, the wax material we filled. Okay, now when we pass this high temperature fluid around that one, this wax, it actually gets the heat and it will convert into liquid. Okay, now it is in solid form, and by receiving, let's say its melting point is 300 degrees centigrade. Okay, so now till 300 degrees centigrade, it is in the solid state, and then it will become the liquid. So up to even like more than that temperature also you can go. Now at 350 degrees centigrade, it is in the liquid state, and this cylinder, we will have good insulation outside. This outside we will have good insulation, so that the heat transfer loss will be less. So now I am storing the temperature of 350 degrees centigrade here inside this wax material. Okay, and
Yes.
let's say because of heat transfer, even though we have insulation, we may lose certain heat. Let's say we are reaching to 320. Okay, then what we will do is, this is heat exchanger, and from here we will pass some water. This water will convert into steam, and this steam we will take here, and then this will run. Okay.
Doctor, my question will is corollary to this, which is that is it practically done?
Yes.
And in the context of the tower, what you had shown, because there it's more predominantly shown. If you can go to that slide, is this the technique used over there for the nighttime,
Yes,
when you're
yes.
not getting the solar power?
Yes. Right. So you store this heat energy in this tank. See here, temperature of that, the material which we will have here, is such kind of the material are available. Okay. Now this will store 500 degrees centigrade temperature. Okay. Now when you
That
pass your water around that one, it will convert into steam, and then you run. Now by varying the mass flow rate of that water,
Mhm.
you can actually, when you pass here, the turbine will generate. If you need 10 megawatt, if you need 5 megawatt, you can generate it.
See, later on part is easy. That's understandable, which is the beyond the steam. My this thing is question is generation of steam. Rest after that is very clear that the
Hmm.
turbine is operating, through steam, and then you get the power generation. The catch is how are we able to consistently generate the steam all through 24 hours?
Yes, see, all are like design. See, that's what you have to do a very good design of the system as per your demand. So let's say I want to install in Delhi some community. I'm taking one area, let's say Noida. In Noida, I want to install one this solar power tower. You need the land, okay? The non-usable land. You put your plant there, but theoretically you have to work out, okay, that I want 10 megawatt during the daytime, night time I want 3 megawatt. Now what is the variation day wise, what is the variation? So this all these things, and then finally you have to come one design point. This is this much of megawatt we want, and by varying the mass for it I can manage it. So before installing this system, because initial cost is quite high, so you have to do all your calculation. You have to go back and see last 10 years, 15 years data of solar. So solar radiation is not changing. It is last year, whatever solar radiation you were receiving, this year also you will receive. Only thing is some climatic change problem, some cloudy season. Earlier, last year, cloud were less, this time cloud are more. So some variation will happen. So that's why you have to see the history of 10 to 15 years, what is the pattern, how much radiation we were receiving. Accordingly, you design your receiver, your tower size, your thermal energy storage tank. Now you have to select one material which will store 500 degrees centigrade, okay, 300 degrees centigrade, and then you have to work out.
Okay.
So by doing excellent
so we have to do
design, you can manage.
Yeah, so we have to do finally the cost benefit analysis and understand whether it is return on investment is there.
Yes. Right now the cost is little bit higher than PV power, but because PV power has problem, see again PV power, see your panel, it work efficiently for maybe 5 to 10 years, then efficiency is decreasing, and 20 or 25 years is its life. But here the life is, you can say 50 years, 70 years, because such component it is not there.
Okay, thank you.
I have a question, Professor. In PV power, one of the issue, as my colleague mentioned some time back, is prohibitive initial cost, maybe about 6 crore per megawatt or whatever. That's the order of magnitude. That may not be the exact number. So maybe I'm just confirming my understanding that solar power tower might have a significantly lower initial cost, but it will have a higher running cost. So in a way, we might be able to, get around that issue of initial cost, and the overall cost might still be comparable. That today people are quoting
No.
two and a half.
Initial cost is higher here. The reason being that in PV power, the panel, see, you need panel and structure.
Okay.
But in power tower, you need this, okay, these mirrors are there. Apart from that tower then you have steam turbine, then condenser. So these things are there, thermal energy storage tank.
So the running cost will also be higher because here we also have to run a turbine.
Yeah, yes. So running cost will be little bit more than what it is panel, what it is there in the panel.
So overall, it will be higher than PV in any case.
Yes.
Significantly.
So that is why it is not coming. I mean, like everybody is not preferring it. Yeah. Those who think for long term.
Yeah, yes. We don't know. I mean, at this moment, that is the situation. Maybe over a period of time, with the help of kind of research which is happening, this might end up becoming the preferred option.
Yes, definitely. And see, as I showed here, see, we are generating 35,000 of megawatt of power. But then again, that night time we don't have the solution. It is a problem.
Yeah.
Here I would like to add one more thing.
Yeah.
Whenever we are talking about the coal-based plant, in the coal-based plant, boiler life is less, and the life of the steam turbine is more. So when the life of the boiler has been exhausted, then we are having two options. Either we can reinstall the boiler, or we can change the type of the plant, because we are already having the availability of the steam power plant. So many such power plants are coming into play due to the higher life of the steam turbine in comparison to boiler.
Yes,
So
good point, I think. Yeah.
when we are having the option to change the boiler, then we can convert this type of plant, steam turbine plant, either solar thermal plant, or generally we also convert this into combined cycle power plant also.
Okay.
True,
Yeah,
true.
that's a great thing. Yeah. Yeah,
Yeah,
they can
yeah.
also use a diesel or natural gas kind of system.
Yeah, we are having one more question from Dave Sudhi. Mr. Dave Sudhi, if you are here, you can unmute yourself.
Good evening.
Yeah, good evening. Yeah.
My first question was, can you give examples of thermal energy storage materials, which I think you've given one example. Are there other material examples?
Okay, 1 minute. What I will do is, actually, because I am taking solar thermal energy course, so I have slides on phase change materials.
Okay,
So maybe I'll share that one so that you may get certain idea.
sure.
बुखार है
You can see this slide, right? So these are some materials. This is we call like non-paraffins. So you see the melting point of this material. So different materials. See, thousands of materials are there. So some I have taken here. Like, so you see here the melting point is like somewhere around 50 or something like that. We have some salt hydrates. You see the melting point is again 40 or something like that. Metallic materials where we have melting point of 125 or something like that, and some other materials maybe I can show little bit higher temperature. See, like some material which will have
And they have high specific heat.
yeah, they have high specific heat.
And,
See, I have not taken that some materials which are having. See that nowadays many materials are available which can store up to maybe like 300, 400, even more than that also.
and are we concerned about their evaporation also?
No, see the material which I am talking, like they will be in solid state, and we will convert into liquid.
And from liquid, what would be their evaporation?
So it will be quite high. Let's say we chosen some material which will have, let's say you talk of let's say metal. Okay, so in metal you can store, say let's say 500 degrees centigrade, it will convert into liquid, and then its evaporation will be quite high.
Correct. Okay.
So
The other, okay, good. Thank you. Other question I have is, what is the reason for low efficiency of PV systems?
Okay. In PV system, what happens is like, so basically what happens is your radiation falls. So this radiation, particular band of, see now the light which is falling, it is having certain bandwidth. Okay. Now out of that bandwidth, particular bandwidth only, it is actually exciting the electrons which is available in the solar cell.
Okay.
Okay, so because of that, I mean, like almost like you can say like 10% of energy only going there. Okay, so for that, what they do is like this is like cells. Then they are using the multi-junction cells, so that like different bandwidth you can utilize of light, and you can actually increase the efficiency, but then the cost is going very high.
Okay.
The panel which we generally get is the cost, whatever cost is there. If you go for multi-junction to increase the bandwidth, your cost may be almost like 5 times higher, something like that. So that's why till now.
And how much efficiency could be improved by
Yeah,
putting
so
white
the
on?
base multi-junction cell which I heard recently, it is having efficiency of I think some 30 or 38 or 39%, something like that.
Okay, so it's not a good trade-off then.
Yes.
Oh, okay. Now, is the angle of incidence of the radiation, is that also a reason for low efficiency?
No. See, if you are having the power plant, then there also like control system will be there, so that like day wise also you can capture more radiation, as well as season wise also you can capture. So in the power plant it will be there.
Oh, all right. Okay. Thank you.
Yeah. Thank you.
Sir,
So,
I
Professor,
have...
sorry.
Any more questions?
Yeah, carry on.
Are there any more questions?
Yes, sir. Yes,
There
sir.
is one more.
2 more questions, sir. Hello.
Yes, please.
Yes, sir. So first thing is like, how can we transport heat energy? As you said in the last 2 slide, there is research work going on that, like logistics of energy. So how? Firstly, this question, and the second question is that like we are seeing the surge in electric vehicles, like at a commercial level, there is slightly more surge, and at personal level it is quite less. But at commercial level, with the surge in electric vehicles, can it be seen as the power storage house for PV solar power generators? Like the problem that you mentioned, there is not a possibility to store uh, energy.
See, the first thing which you ask is like how we are storing the heat in the material, right?
Transporting, sir, transportation. Like you were telling about transportation of energy from one place to another in the
No,
last 2 slide.
we are not transporting, right? We will have plant, and in that plant only we will have the materials, right? And there we will store, and that heat we will give to the turbine. So that is plant. So when we generate the electricity we will transfer through grid.
No, sir. You said some industry might need heating. For example, heat treatment plant need a lot of heat. So if we are generating, we have a power plant at a certain location, and we are generating heat, and we need heat at some other location. So can we able to transport that heat?
Yes. See, that is quite common. Actually, if you see in European countries or Canada or US, where the temperature goes very low, right? See, I mean, like temperature is in minus also. So there, what they do is like in the power plant itself, the plant, it is generating the steam only, and that steam it is supplied, or hot water it is generated. This hot water through pipes it is given there in the residential areas or industries.
So this, for example, this I just to add, Professor, to yours, like Russia, for example, where the temperature touches minus 20 to minus 25 in the Moscow city itself. So there are huge district heating plant
Yeah,
where
district heating, right.
where they generate the steam, and the steam is then circulated throughout the city during those 3 or 4 months time, and then there is an additional heat exchanger at each junction where they they take out the hot water from there for their utility purposes. So this is
Right.
how it is being generated in cold weather conditions. Finland, Sweden, Russia, this northern belt basically close to it.
Right. So that we call district heating, right?
Yes, sir. The second question was about, sir, electric vehicles. Like we are seeing a surge in use of electric vehicle at commercial level. So can this be thought of as the power storing house for the PV generators at the peak hours?
Yes, that is possible. I mean, see, this is what like open area. Now you have to, I mean, like people have to come up and then get the solution. Now this is the problem. Now there may be 1,000 solutions possible, but then everybody has to, I mean, like everybody has to go and explore that solution. You have to do the experimentation and get that what is the efficiency. And then you can propose, you can do the experiment, and then you report it. So if community feels that this is encouraging result, they can move ahead with that one.
Yes, sir. Okay, sir. Sir, one last question, like mass flow rate, with the varying of mass flow rate, are we underutilizing or wasting the surplus or not?
Which one you are talking?
I think he's
See,
talking about the temperature, the flow for the steam turbine.
No. See, you stored the energy, but now, see, when you are passing less mass flow rate, you are passing means you are you using less heat. So let's say this was at 300 degrees centigrade, it will go to 270 degrees centigrade. If your mass flow rate is higher, this instead of 270, it may go to 250. Okay, so there is no issue. You are actually storing it. Let's say 270 you utilize, but then 270 it is available next time.
Okay.
And also, I think with mass flow rate, you are optimizing your energy usage.
Yes.
By not keeping it constant, if when you are varying it, you are using what you required, so that you can use it for longer hours. Otherwise,
Right,
if you keep constant, then
Yes.
you will waste your stored energy.
Right.
So that too is counted with efficiency.
No, but then I mean this is very easy. It's not very difficult. I mean
Okay.
constant flow rate. I mean never you will have even like smaller system also you can have varying mass flow rate.
Is there any more
Thank you,
questions?
sir. Thank you. Very informative.
Is there any more questions from participants side?
So, Professor साहब, निखिल साहब, ये presentation जो आपने कुछ slides share की थी, you are going to share with us also, right?
Actually, sir, every lecture will be available online on the YouTube, and I will be sharing the link of the lecture on the group for every lecture. Last two lectures I have shared, and today lecture also I will share within 1 hour.
Okay, thank you, sir.
Great, thank you.
Thanks a lot. It's a really good lecture, and appreciate you, Dr. Nitin and Dr. Nikhil. Thanks a lot.
Yeah, it was like quite I mean, I also felt like nice because people are aware and then they are coming up with a question which I mean this is what we require actually to come up with a better solution. It was like very nice discussion.
This topic is very interesting actually. Because
Dr. Nitin, you have made it
Thank
more
you.
interesting, you know, your content in the slides and, you know, the way you have presented made it very, very easy to understand. Like for me, you know, we heard so much about solar, but I think for the first time, we really think that we, you know, understand a little bit about the process and at what stage we are in India. So really appreciate.
Yes.
Yeah, thank you very
may I
much.
ask one more question? As compared to
Sure.
wind power generation, so which is better? I mean, the cost of which electricity is less? If we generate through wind or through solar?
See, wind power, it is location specific, and but then once you have good wind power, then your cost will be lower, and maybe you might be surprised that right now the wind power is higher than solar power right now in India.
I see.
Is there any more questions, participant side? So, on behalf of JC Bose University of Science and Technology, YMCA, I thank all the participants and our speaker, Dr. Nitin Nankar, for being with us and giving us such valuable time. Thank you, sir. Thank you, all participants.
Thank you very
tomorrow,
much for
6:30.
the invitation. Yeah, nice discussion.
Thank you.
Okay, thank you.
Thank you.
Thank you.